Before we move on to our graphical representations of these acceleration equations, let's take a look at sort of a summary. Let's summarize. In your notes, I would like you to put a single summary of the equations that we've seen so far. I'm actually going to list one of the equations twice, and that is that the initial definition of acceleration was delta v over delta t. Okay, now remember what we did with that equation was we took the delta v part, we broke it into v minus v naught, and that gave us this equation, that v was equal to at plus v naught. We took a different approach to looking at average velocity, in which we simply added the two velocities. And then multiplied that by the time in order to get the displacement. We then took these two equations and we combined them together to produce two new equations. The first one was 1/2 at squared plus v naught t, and our last equation was v squared equals v naught squared plus 2a delta x. Now what would really be wise on your part, besides having these equations summarized, is to have an index card. An index card that you could keep handy with you that would not only have these equations but also the velocity equations, and this would be a way for you to reference the equations. Remember, they'll be given to you. You don't actually technically don't have to memorize them, but you really should become very familiar with them to the point where you really have essentially memorized them, because if you have to look back at these notes all the time to figure out what equation you should use, then obviously that's a very time-consuming process that on the quiz or the exam is going to eat up a lot of time that you really could use better for solving the problem or working out the details of what's given to you, or plugging through the algebra or the calculations. But this essentially summarizes the equations. We're going to see most of these equations we're going to see again, and we will see them in the form of the graphical representations. We're going to look at slopes and areas of graphs, and you're going to see that these equations will come back up again, particularly the equations which have time. We probably won't look very much at the graphical version of this last equation, but these first three you're going to see, actually the first four, you're going to see these equations in graphical form in the very next video, in fact.